So we're going to look at number 2 first from last night's homework. Can everyone at home hear me all right?
Yes.
This is page 258 from last night, correct? And like I have mentioned before, when you are doing these net drawings, you don't have to draw the original figure if you're not comfortable drawing the original figure, but you do have to draw the net version of it. So number 2 on page 258, you should see what type of figure is this that we're looking at. What type of figure is this?
Pyramid.
It's a pyramid, and the base is square. So we can even call it a rectangular pyramid because its base is rectangular shaped, right? So let's unfold it and get some dimensions transferred over to that net, okay? So 7 is my height, and 8.8 is my width and length of the square. So what would it look like unfolded? What would the bottom face of this structure look like, everybody? A square, okay. And then what shape fans out from the square? Triangles on all edges, right? All of these edges have the same triangle folding out from them, right? Let's transfer a couple of dimensions here. So the length shown here at the base of the square is what? 8.8. So that represents the same length here. That's 8.8, as well as the depth of the square. That's also 8.8. And that's all we need to know to calculate the area of that region. We need to know the length and the width. We'll label that shape A because that is the only one like it. Now those other shapes are triangular, right? And they have a height of 7 and a base of 8.8. And we can see where they're connected right here. But they all have a height of 7. Their height is 7. And they're all exactly identical to each other. We'll call all of those, let's call them B, okay? We'll call all the triangles B because they're exactly the same shape and size. So give me a formula that proves the total area of this space, of this shape. Give it to me. Total area is what? 1 of the A's plus 4 of the B's. Good job. So 1 of the squares and 4 of the triangles. Now, when I'm calculating the area of that square, I need the length times width formula, right? What's the length? What's the width? 8.8 times 8.8. And maybe I'll just type it right here on my screen instead of having you guys calculate it for me. 77.44. Do we get that? 77 and 44 hundredths. Good. But what about B? Do I still use the length times width formula, or do I have to use something different for the triangle? What do I have to use? Base times height divided by 2. Okay, so the area formula for a triangle is a bit different. Make sure you have this down. What is the base of the one of these triangles? What's the base? 8.8 times, what's the height? 7. And then we will divide that figure by 2. Anyone have that amount?
Wait, you want like?
I want 8.8 times 7 divided by 2. 30.8?
Yeah.
Good job. All right, so now I'm going to evaluate taking the value of A and plugging it into my formula. So the total area is going to be 1 of these plus 4 times 30.8. So 4 triangles and 1 square. So far, so good? What would the total area be if I first multiply 4 times 30 and then add 77 and 4400. Lucy, what do I get? 264. Anything else?
Wait, 200.64. Yeah, 200.64.
Like this?
Yeah.
264 hundredths. Now give me my units.
Meters squared.
Meters squared or squared meters? Meters squared. How are we with that figure? Okay. Now I know number 3 involves some fractions, and that was tricky. I'll tell you tomorrow on your quiz, you won't have any with fractions.
Okay.
You're welcome.
Are we allowed to use our calculator?
Yeah, you can use a calculator for it. And in fact, you can use your notes. You can use your notes. Remember that little cheat sheet I gave you?
Yeah.
Do you want me to pull it up on the screen?
So say we can just write that in a notebook.
Let me show you. Going back to where we began this topic. Area formulas cheat sheet right here. This is something that you'll be able to use. This was the first side of it, right? It had the dimensions of all the different shapes. So the area formulas, right? And then you could also use, let's see. Nope, it's on today's post. You also use this guy. Calculating surface area with nets. And I think this was copied on the back of your area cheat sheet. Do you remember that?
Yeah.
Okay, so we've got description of prisms, descriptions of pyramids, a little clue on how to unfold a prism. Is this helpful? Oh, here's the back. That's right. All right, so what we're going to do today when we dismiss from our Zoom is you're going to tackle these 2 problems and these 2 problems. Okay? And they'll be very similar to what's featured tomorrow on your quiz that just covers sections 15.123. So you'll be expected to kind of match 3-dimensional figures with their nets. You'll be expected to say, here's a prism, unfold it. What does it look like? And calculate that surface area using these techniques we've done over the past few days. We're going to do one more of the pyramids right now, Paige, and then we're going to do one more prism. And then you guys have 4 more problems to try and practice for your independent work today. And I'd be happy to post an answer key later on this evening if you feel that would help you. Okay? Any questions? Let's do number 3 from last night's homework. This one involved the fractions, right? So I'm not going to even bother drawing the 3-dimensional version. I'll just go right to the net. Again, we have a square base. And what are the dimensions of that square base? 1 1/3 by 1 1/3. The triangles that surround it are pretty steep, aren't they? They're very pointy and tall. Their heights are very high. I'm going to write the heights in a different color just so they kind of draw your eye a little bit differently. The height of these triangles are 5. The bases are the same as the length of the square, which is 1 1/3. All right, same as always. How do I calculate the total area of this shape? I have one shape that is, we're going to call it A. And how many shapes that we're going to call B? 4, right? 4 identical shapes that we can call B. Room 201 really liked it when I added a little color to it and they said, okay, that one's going to be A and this one's going to be B, and they could more visually see what shapes they were looking at and how much space they kind of occupy. So you can use color if that helps you understand the problem a little bit more. Either way, we're going back to the fact that we have to solve area for one square and one triangle, and then combine those with this total area formula. All right, how do I solve the area for shape A? It's a square. What's the formula for area of a square? Length times width. All right, so here I go, length times width, 1 1/3 times 1 1/3. Pull out that memory of how do I multiply mixed numbers? Can't do it, right? What do I have to do?
Around the world.
They have to be converted into fractions in order to act like fractions. Then we can just snap across. So I think we kind of called it this like around the world trick, where we convert them into improper fractions. What is 3 times 1 plus 1? 4. Keep the denominator, thirds. All right, same thing. 3 times 1 plus 1, 4/3. Now can I snap across and multiply? Yes. What's 4 times 4? 3 times 3. All right. So we know the area of this square is 16/9. We know that. We can even plug it in this formula now. How about B? B is a triangle. What's the formula I need? Base times height divided by 2. What's the base? 1 1/3. What's the height? 5 divided by 2. Can I carry this over here so that it's a little less tricky to deal with? All right, we've dealt with division of fractions before. Let's convert the 1 1/3 to 4/3. Times 5 would be 5/1. Divided by 2 would be divided by 2/1. Now just take it piece by piece. What can we do first? Multiply. Let's multiply. We will when we get to that spot. Yep, you're right. Someone mentioned, hey, wouldn't you use the reciprocal when you divide? Yes, you would. But let's do the multiplying first, because order of operations says handle whatever comes first with multiplication or division from left to right. So multiplication comes first. Bye, Santo. What's 4 times 5? 20. And 3 times 1? 3. Now drop down the rest, divided by 2/1. Now you remember from division of fractions that in order to divide by a fraction, you're actually multiplying by its reciprocal. So keep, change. Or what is the other catchphrase we said? Keep the guy and, what was the other one? Flip the guy and multiply, something like that. I like keep, change better. Because you keep the first term, leave it alone, 20/3. You change division to multiplication, and you change the 2/1 to be a 1/2. So here we go. Keep, change. So we end up with 20/6. That can be simplified just a touch to 10/3. So now we know what 1b is. What would 4b's be? What would 4 times 10 be? Here, I'm going to move some of this out of the way. Good job. 40/3, yes. So we're getting closer. We have 16/9 plus 40/3. Can we add them together just yet? Why not? They don't have common denominators. This is like the ultimate 6th grade problem. It honestly touches everything we have done this entire year, except for like decimals. Paige, I got 40/3 because you see this big 4 out front? What is 4 groups of 10?
40.
40. So that's how I got 40/3. All right, we need common denominators. What's the common denominator between 9 and a 3?
9.
Yes, so the first guy stays the same. That's nice. So how would I change this term to become a denominator of 9? What factor would I multiply it by? Times 3, right? What's 40 times 3? Ooh, we're getting close. Can we combine them now?
Yeah.
Yes.
136/9.
136/9. Can that be simplified at all?
Yes.
How many times does 136 can be split into 9? Is it even or not? It's not even. It's not even. Not a pretty whole number. I think it is just 15 times. 15 whole times with one left over. Oh, they can't see it. 15 whole times with one left over. Does your brain hurt?
Yeah.
There will be nothing like this on the quiz tomorrow, but I thought it would be fun to kind of touch on all of the little topics that we've covered this school year. Factorization, common denominators, fraction operations, geometric shapes, just all of these things kind of colliding into one problem. So yes, this is my number answer, but what are my units? Yards squared. Dun, 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 dun. Okay, 15 and 1/9 yards squared. Phew. Can we get back to like a basic one that we're gonna be able to do on a quiz tomorrow? Okay, very basic. Last one, and then you're gonna do your group work. Everyone copy this guy down. Draw me. It looks like a cereal box tipped on its side.
Yeah, but.
I want to review a prism before you guys work on your own. I want to review a prism.
Wait, how do you draw that?
Yes, Paige?
How do you draw that?
Just give it your best shot. You won't have to draw a three-dimensional shape tomorrow. You only have to draw the net of it. And the page you can go for help with that is 253, is where how you can convert a three-dimensional shape into a two-dimensional shape, a flat shape. But how I started, Paige, was I thought about what am I looking at? I'm looking at the rectangle front, and then I kind of draw parallel lines to show the dimensions heading back, that depth, and then I connect them with other parallel lines. And it doesn't have to be perfect. This takes practice. So here's my dimensions, guys. We have 5 meters going along the front edge. This is going to be 7 meters going along the length, and then 2 meters going along the height. So are you liking these basic whole numbers? Is this easier? Unwrap it for me. And if you need to look at 253 in order to draw what this looks like, go ahead. 253 will show you what a rectangular prism looks like unfolded. What my class seemed to have the most success with was envisioning, this is what I'm going to draw first, is whatever is on the floor. So which shape is on the floor? The biggest rectangle. Would you agree? The biggest rectangle is flat on the floor. And that biggest shape has a congruent partner, which is on the top. So the bottom and the top are exactly the same size and shape, but they're opposites of each other, right? They have 2 thinner rectangles that are between them. So in order to draw this net, I have to draw the left and the right kind of between the top and the bottom. So I have the big bottom, the thinner side, the big top, then the thinner side. And then this front and back face can just kind of fall wherever I choose. I think I will connect it to the bottom face. That seems easiest for me to understand. I don't know about you, if that makes the most sense for you. The front and the back kind of fall to the ground off of the base. Okay so far? I need some feedback. Okay so far? Yes. Let's label with some dimensions. What's the longest segment length? What's the longest segment length, class? 7. Okay, let's label it. 7. That's all of these. 7, 7, All of them are 7 all the way across, right? You don't have to label all of them. Just label enough of them for you to get comfortable with what you're looking at. Okay, what's the length of the shorter side that's also on the bottom? What's the length of the, so that's going to be here. Are you guys all copying this onto your notes? Okay. What about the tiny one? 2, that little tiny one, 2. And it's glued over to this guy, 2. That one's a 5. Here's a 2. Here's a 2. Yes?
So for the rectangle, I did it a little differently. I put one of the sides on the left.
Sure.
Okay.
How are we with this so far? How are you guys at home? Are you understanding how we turned this prism into a net, into a flat shape, and how the dimensions apply? I'm seeing smiley faces in the chat room, so that's good. All right, now comes the easy stuff. Let's put some color on it. If you don't want to label it with letters, label it with color. Where is the other shape that is red? Skip the little one, right? These are equivalent, aren't they? They're congruent. Those two are the same. I'm going to call them A because they both are exactly congruent. What about the next kind? Are there any more that are congruent to each other?
Yes.
Mm-hmm. This one's congruent to which other one? So the top and the bottom are congruent. The left and the right are congruent, and we'll label that one B. And then what about the front and the back? Are those guys congruent?
Yeah.
Those guys are congruent too. Good. And we'll label them C. So it's kind of like a puzzle. I see all the pieces, and I know my total area will be A plus B plus A plus B plus C plus C. Or in a shortened version, I could say 2 A's, 2 B's, 2 C's. So total area, 2 A's plus 2 B's plus 2 C's. Let's find the area of each and then apply it to our formula, okay? What are the dimensions? They're all rectangles, so this is all easy, length times width. What are the dimensions of rectangle A? What's the length? What's the width? It's a 5 by 7. What's 5 times 7?
35.
Good. What are the dimensions of rectangle B?
2 times 7.
2 times 7. What is 2 times 7?
14.
Okay. And the dimensions of rectangle C?
2 times 5.
2 times 5, which is 10. Good. Plug it into the formula and we're done.
Wait, don't you have to multiply?
Yep, we're plugging into the formula now. What are 2 groups of 35 plus 2 groups of 14 plus 2 groups of 10? Okay, that's what we're figuring out now. So we have 2 A's, we have 2 B's, and we have 2 C's. Can you figure that out? 70 plus 28 plus 20. What's our grand total?
118 meters squared.
118. We're dealing with meters in the second power. Okay? So what I'm going to do is pass out this worksheet here to my friends in 200, and they're going to be allowed to work on it with another person. Hey, whatever you don't finish, you need to finish as preparation for your quiz tomorrow. So I'm collecting this as a study guide.
Are we doing volume on our quiz?
No, no volume. Yep, just this.
So just what we did yesterday at the.
Yep. You can work on this together
So I'm gonna pass it out.
or by yourself. And yes, you can use a calculator. All right, guys. Talk to me. How are we feeling on a scale of 1 to 3, 1 being I feel like I'm terrible at this, and 3 being I'm awesome at this? Where are you feeling? Be honest so I can help. You can type it in the chat box, okay? Oh, I like that. 2.8. I like that. I can gauge. All right, I'm sensing that we're feeling comfortable enough to try some of the independent ones. And if you want to stick around and I'll start doing some of them with you right now, I can. I'd be happy to post the answers later on tonight. We can chat again tomorrow before the quiz, but I think you have the tools you need. You're going to be able to use your cheat sheets tomorrow, calculator. Just got to understand how to unfold it. That's the hardest part. And then all the rest is just about organization and labeling, okay? So you're free to go now and work on those 4 problems, or you're free to stick around and work on those 4 problems. But I'm going to start rolling through them now, okay? All right, let me pause this.